The broadcast is now starting. All attendees are in listen-only mode.
This webinar will begin shortly. Hello everyone and welcome to today's webinar. Today we are joined by Aaron Fox. He is with the company SmartBear and the webinar is Laying the Foundation for Enduring Success, Elements of a UI Automation Framework. We have our conference next week. We will be taking to The Hague, so if you haven't got your ticket already, there is still time. You can head over to our conference page. If you would like to ask Aaron a question at any time during this webinar, please put your question in the chat box in the right-hand side of your screen and we'll get to a Q&A at the very end of this presentation. So without further ado, I'll hand over to Aaron.
Thank you very much, Kleena. Before I go any further, can I just confirm that you can see my screen and you can also hear me?
Yes, I can hear you, yeah, and I'll just put the question out to the attendees. Yes, everyone can hear you?
Fantastic, and you can see my screen okay?
Yes, perfect. Thank you, Aaron.
Fantastic. So good afternoon, everybody. You're very welcome to our webinar today, Laying the Foundation for Enduring Success, Elements of a UI Automation Framework. My name is Aaron Fox. I'm a technical engineer with SmartBear Software based in Galway, Ireland on the wet and cold West Coast. And over the course of the next half an hour to 40 minutes, I'll be taking you through what we need to start thinking about when it comes to setting up a test framework. I primarily work in the front-end UI test and automation space, and I talk with people every single day that are constructing POCs, that are looking for the best testing solutions for them, whether it's through tooling, whether it's through processes, or just framework setup. As Kleena said, any questions, please put them in the box, and we will have sufficient time at the end for Q&A. And I'll try to answer any questions you have the best I can. So the big question is, what is a test framework? Okay, and when people think about test frameworks, they often get derailed by thinking straight away about automation, and they start thinking about pipelines such as Jenkins. They start thinking about how they're going to take all their scripts and are going to run them. They're looking at the overall picture and the end result before they're looking at what the individual components are and how they need to fit together and sync with each other to get an effective and reliable test framework. And it fundamentally relates back to the software development lifecycle. So this is just a portion of the software development lifecycle I have taken, but these three elements are fundamental to how we would start to think about setting up a test framework. So firstly, we have our requirements. What do we want to build and how do we want to build it and how should it be built? This comes back to your users. Who is going to be using your application? What are they going to do with the application? What is the most common behavior that they are going to perform on the application? From there, then, we can start to develop tests. Does it work as the requirement state? If we define that it needs to do A, B, and C, does our test cases address A, B, and C? Do our tests provide the sufficient coverage? Do they provide sufficient functional testing? And are they reflective of what's really going to happen in a real world scenario? One of the big questions that comes again and again and again is I have all these test cases, but they don't really work for me. And a lot of the time it's because people focus too much on the functional element of getting their website or their application to work just as the requirement states, but they're not really taking into account real world scenarios, which in industry today, it's what it's all about. It's about replicating your real world scenarios in test environments, and it's about having tests to test those real world scenarios. And then finally, the defects. A lot of people don't like the word defects. There's a lot of developers that I know that think the word is the no-go area, but the more defects you have, the more insight you're getting into your application, the more insight you're getting into what your users actually want. If you send an application for user acceptance testing and you get a whole load of defects back, well, then it gives you a real good insight into what your users are actually going to be doing, what is of value to them, what sort of workflows they're moving through, what sort of actions they're performing. And that can be reverse engineered back through our requirements and test cases to ultimately build a much better test framework and application for your end users. So throughout the course of the webinar today, we are going to be referencing the software development lifecycle, but we're going to be referencing these three areas: defects, requirements, and testing. And if you can master these three areas within your organization or your company or your development team, well, then you're well on the way to having a strong test framework in place. So with that in mind, what does a test framework look like? So it links tests to other items of the software development lifecycle. One of the most important features of a test framework is that everything is linked and integrated together. Now, that doesn't mean that every tool or system you're using has to have an integration or a plug-in to another. It's more from a communication and people perspective, where your requirements are linked directly to your testing. Those tests are linked directly to the environments you wish to cover and test. And any defects created can be reverse linked back into those environments, those tests, and those defects. A test framework is not a test automation framework, but it often contains one. And again, this goes back to a common misunderstanding people have. Is my test automation framework the same as my test framework? I can automate all of my tests, therefore I have a strong test framework. And that's not always the case. A test framework is a collection or a workflow across your tests, requirements, and defects, whereas test automation is more around taking out the manual and laborious tasks and tasks that could be susceptible over time to human error to provide you more frequent testing and faster test results and more accurate test results. They're not the same thing. But most test frameworks will often contain some elements of automation. In fact, to have the best test frameworks out there for your company, you probably should include some elements of test automation. And we will talk about that later on. You want to create a situation where you can rapidly develop tests, and with those tests, reusable components. When you start putting together your requirements and your test cases, it's going to be quite obvious early on that you're going to have a lot of repetitive tests. You want to have a lot of repetitive requirements and scenarios that you're going to have to test. Regardless of what you do with your application going forward through your various release cycles, you're going to have your bread and butter foundation tests. You don't want to have to recreate them every time. It costs money, it takes human resources, and it takes machine resources. It also takes a significant amount of expertise. Bearing in mind when we talk about testing, you always want to create reusable modules and components that you can call upon at any time to perform a specific test. A great example of this is a simple, let's say Amazon. You log into Amazon, you place an order for a product of some description, and you log out. Every time you have a new release, you don't want to have to rewrite login code. You want to have a login module, which at any stage you can call upon to execute that piece of a test, regardless of what state your application is in, regardless of which release you're in. That feeds into the next point, separating data from logic. Our data will always be changing. For example, if you're doing data-driven testing or end-to-end testing, you're going to want to have huge amounts of data, mock data, virtualized data, dummy data that you can feed into your application and readily restore at any time. To be able to accommodate that and handle all that, you need to have all of your logical components in a reusable state. And finally, which I think is of utmost importance, if not probably the most important point on this slide, providing a standardized test language and reporting structure for the application. In my role day to day, I am more and more speaking with people and companies, and they say, well, my test team, they're not all technical. Some of them actually have a project management background. Some of them have a business analyst background. So it's not really suitable for us to be writing code or to be overly technical. This is what we talk about when we talk about bringing everyone under the one umbrella on a test team, bringing technical and non-technical resources together and creating a test framework that allows everyone to collaborate together. There's a lot of tools on the market right now where you can either script, which would cater for your more technical users, and in the exact same tool, you could, for example, take a codeless approach, such as a record and replay function, which is available on several tools on the market for UI testing. It's a fantastic way of bringing everyone under the one roof and allowing everyone to contribute to all phases of your test framework. With all that in mind, let's talk about how would we build a test framework. And it comes back fundamentally to the 3 Ds. Define is the first. And typically this is the easy part. When we're defining, we're looking for 4 things. We're looking to define our requirements, define tests for those requirements, define the workflows that we're going to move through, and then define user stories. The first 3 are fairly core. The 4th is a bonus, but we'll get there in a moment. We're talking about requirements. We're talking about, again, as we mentioned before, what do we actually want this application to achieve? What type of tests do we want to write, and what exactly do we want these tests to uncover for us? We don't have to test every square inch and every line of code of our application. That's not necessary. Sometimes we could have an application that could be 10 years old, and there could be components of code in there that might never have been tested because there is no need to do so. So we need to define exactly what has to be tested, how it's going to be tested. And that again relates back to the users. What are they going to be doing? What sort of actions will they be performing? How are they going to use the application? And that's where our testing effort should focus on. With that in mind, you build your test cases directly from that. Like I said previously, you don't want to focus solely on functionality, because by doing so, you're just or you're just verifying or reaffirming that the correctness of the application. You could send it out into a live environment. It can functionally perform perfectly, but it could be really difficult to use. It could be clunky. The workflows could be all wrong. The customer is not going to appreciate that, and it's not truly reflective of how they would like to use the tool. That leads us on to defining our workflow, identifying and detailing common workflows through the application. To do this, you do need some form of user acceptance testing. You need to get prototypes or stubs of your application out into the domain, and you need to let people work with it. You need to let people work through it, analyze and study the common workflows. What are people doing the most? What, for example, going back to Amazon, people log in. What do they do when they log in? We know it starts with a login. We know it finishes with a log out. What do they do in the middle? What are the most common paths they take? Maybe they place an order, return to search, place another order, return to their shopping cart. Another user could do something completely different. So it's defining and identifying these common workflows and creating the appropriate tests. If you're one of those lucky people that work in a team that is matured from an agile perspective, then you're mostly halfway there, because user stories are a fantastic way of doing everything we've spoken about so far today. If you can have your sticky notes and you can write your user stories, you can very quickly build up the bones and the ideas that you want to implement in your test framework. And believe it or not, people get bogged down with test frameworks thinking, okay, we're going to have to configure this tool. We're going to have to configure that tool. We're going to need to code this and code that. That's actually the easy part. The hard part is nailing down exactly what the requirements are, developing those tests and ensuring they have sufficient coverage and the workflows. And with user stories, that's a great advantage. So in this example here, we just have some smart forms, and the arrow represents the flow through them. So this goes back to our workflow. So on this first form here, we can see we have an input. We have input URL, input email address. We upload a file, we can put the text into a text area. So just to give you an example. So user one could input an email into the email box. They could write a paragraph of text, and they could select from the select a single arrow dropdown. They could upload a file, and they could move on to the next window. In the next window, they could do something completely different and move on to the third, and so on. That would be one workflow. User number two might only input their email address, and they might do nothing else, and they might move on into the next window. User three might interact with every piece of every control on this UI and move on to the next window. These are all examples of workflows which need to be tailored for. For example, someone told me a story one time of when they were testing an application, and with the application there was two options. There was option A and option B, and the requirement was the user selects option A or option B. And when they rolled this out into the live environment to their customer base, nobody ever considered what would happen if one of the customers decided they weren't going to pick A or they weren't going to pick B. They were just going to move on and skip that step. It was never considered, it was never thought of, and as a result, it was never catered for in the application's functions. Very early on when in the go live, probably a day or two in there, a user did exactly that. They skipped option A and B, and the entire application crashed because no one had considered that this was a possible workflow. The second D is decompose. So we want to now take all the information that we've got, and we want to break it up into various pieces so we can better understand what is happening and what needs to happen. So the first is actions or inputs. Going back to our forms for a moment, what are our users inputting? What fields are they interacting with? What sort of data are they putting in there? Depending on the inputs they supply and the controls they interact with, what actions come out of that? the workflow logic. What logical modules, what logical stubs or methods are being brought into play based on what the customer or what the user is providing and what controls they're interacting with. And then how does the user leave the application? For example, going back to Amazon, do they just log out? Do they just hit the close button and not log out? Do they just shut down their laptop completely? Let's go back to our form for a second. Here we have inputs, as we've mentioned already. The user inputs their URL or phone number. The user selects values. The user enters text or uploads a file. What is the output of that? The application may display a message or a prompt, or it may change state, so it may move to another window, or different controls might appear or disappear. When the user is finished, what do? They might close the application, or they might continue past this window and move to a next window. They might not do any of that. They might not fill anything out and proceed to the next window. Or as we said, they just might shut it down completely. All of this needs to be catered for and carefully thought out. And the third D is decide. And this is huge. Decide what environments and contexts you would like to cover. So one of the big things here is you can never tell exactly what your customers are going to work with. So if we take a web example, is it safe to do the old reliable and say, if it works on Internet Explorer, it's going to work on everything else? I don't think so anymore. We have so many different browsers. We have Firefox, Opera, we have IE, Edge, Chrome, Safari, and we have several different mobile browsers as well. We need to create test scenarios that cover all of these. What about operating systems? Again, if we have an application, is your user on a Linux machine, or are they using a Mac or a Windows, or are they accessing it through their phone, in which case probably iOS or Android? If they're accessing it through their phone, or in fact trying device in general, what is it? Is it an iPhone? Is it a Samsung? Is it a Hawaii? Is it a tablet of some description? What size is the screen? How does it appear resolution-wise? If they're using an operating system, are they using two screens? Are they using one? Is it off a laptop? It's again off their phone. There's so many different variables here that have to be considered. And finally, the users. What type of users are these people? Is your application catered for people who are technical and who would be used to navigating around applications? Or is it catered, for example, to people who wouldn't be technical and may appreciate a much nicer workflow and a very simple UI? These are all considerations that we need to make. But of course, it's not that easy to decide what to cover and what not to cover. On the surface, sure, let's cover everything. But if we were to cover everything, we'd never get anything done. So we need to be quite strategic. We almost need to poll or consult with our users through user acceptance testing. What are they using the most? What sort of platforms? What type of devices? And what's the profile of the people who are using it in terms of how their technical ability, how easy do they find this tool to use? And then there's a load of other different layers that need to be considered. What about, for example, security? Security can change drastically depending on what type of configuration you're using. Or what about conflicting software? So how do we handle a situation where the user is using our application, but they have some other piece of software on their machine that actually affects our software? How do we know that? How do we cater for it? These are all considerations one has to make. Other decisions that have to be made are what tasks repeat. If we want to build up a test automation framework, we need to have libraries. We need to have libraries of scripts, of helper functions, of modules, of data sources that we can recall at any time in our regression testing. It's a built-up history and repository of all of our testing activities and what we're going to do in the future. But to do that, again, we can't just back up everything or have everything readily available. We need to, again, be smart and strategic. So we need to find things that we're going to repeatedly do, such as find commonly used actions. If a user is going to do something again and again and again, we've seen evidence of this and we can bank on it, such as logging into the application. If that is the basic requirement to use it, well, then it's probably a good idea to have functionality and scripts and functions available to facilitate that action quickly and being readily available in a test. And then you're also looking at actions which use the same data. It can be quite expensive to hold data, whether you're storing it yourself or you're storing it through a third party. It can be quite expensive to have that type of infrastructure. And then managing that data, and with all of the new security laws and user data protection out there, that can be quite tricky too. So you want to make sure that any data you're holding is of absolute value to you. And you need to find actions that use the same data again and again. For example, if you have Amazon and you're testing Amazon and you have a product category that contains 1 million products, but statistically you can see it is rarely, if ever, used by your customers. I don't know what type of product that could be. I'm not going to speculate. Why would you store all that data when you know it's going to be very, very rarely used? On the flip side of that, it's probably worth storing mock data for mobile phones or video games, because Amazon probably has searches for them almost every step. The next decision focuses around what do we automate? And again, this goes back to the whole idea of people want to automate everything. Automation is the new buzzword in IT. People want everything to be automated. And they'll always try and find some way of working automation in there somehow. I've seen some potential customers try to automate things that really shouldn't be automated. And there's a fine line that needs to be established. Things that you should consider automating are your environment setup and teardown. So if you, for example, if you're using a web application and the application, let's say, only runs on Chrome, well, then you want to have all of the different environments and versions of Chrome across all the different operating systems readily available. Whenever you want to conduct a test, you don't want to have to go onto your VM, install a particular instance or multiple instances of Chrome. It takes time, it slows everything down, and it's not efficient. So you want to have all these environments readily available. Data entry. Again, if we go back to our smart form, it would be very laborious and mundane if we had someone physically sitting at our PC testing 500 user forms, when we can automate that process by having some type of software or script automatically input the values into those forms. Tasks with high reuse value across many workflows. And again, this comes back to, for example, the user forms. If we know that a workflow contains the same 2 or 3 steps again and again and again, there's no reason to have someone manually sit there and execute them again and again and again. We can write scripts for that. There's software out there that will rerun those scenarios for us that we need to avail of. Then you have your non-functional tests, such as performance testing. It's going to be very difficult, if almost impossible, to manually perform a load of performance testing. If I was to manually conduct a performance or load test and I wanted to use 10,000 users, where am I going to get them from? Am I going to send a company-wide email and tell everyone at 3 p.m. today, I want you to visit this website and execute this workflow? That's crazy. So performance and load testing is something you should absolutely consider automating. And then finally, the repetitive or boring tasks that are prone to inattention errors. If you have somebody, and I've done it myself in previous testing jobs, If you are sitting there and you have 500 pieces of data or rows that you have to input into a system for testing, you go into autopilot probably after about 50 rows. And you'll get to row 300 and then you'll say, did I actually do row 280? Or maybe I have no recollection of doing the last 20 rows. Did I do them? Did I do them correctly? So anything that requires attention span, anything that's just going to repeat itself time and time again, I would try to automate that. When we talk about automation, tooling is important. There are a lot of tools on the market which allow us to automate so many different elements of our testing. For example, our functional testing, our load and performance testing, our test management, such as our code base or our tests or our scripts, and then your pipeline, such as Jenkins, for example. A very simple idea of an automated test framework would be you have a functional testing tool which can automatically pick up and execute your scripts. The results of those scripts will be sent to your test management system, and they will be passed or failed. Defects will automatically be created from that test management system for failures. But how is all that run? All that is triggered through, for example, a Jenkins job that happens at 3 a.m. in the morning. So your results are readily available when your employees come to work. Maybe every week or bi-weekly, you will have a piece of software, which again is triggered through your test management system or through Jenkins or any other pipeline, for example, that will execute your load and performance tests and give you a report. But a common mistake a lot of people make is they get too bogged down on what type of tools are out there and what type of tools the company next door using or the development team down the hall are using. Look at your own application and your own requirements and your own tests and pick the tools that best suit you. Don't be worried about what is the best tool or what is the most inexpensive tool or what is the tool that everyone is using. Everyone's situation is different. For example, a company in the motor industry is going to have very different testing requirements, most likely, to a company that works in the medical industry or that works purely in IT or telecoms. So what I'm really trying to say is pick a tool or tools that best suit the needs of what you're actually trying to do, regardless of what those tools are. I often speak with customers and they say, we're doing this and we're using this tool, but we don't like it. And why don't you like it? Well, maybe it's a bit older, it's a bit outdated, or other people are talking about these tools. Well, is this tool meeting your requirements? Yeah, it is. Why change it then? Then finally, just the elements of the test framework. We've thought about how we put it together with our 3Ds, our define, decompose, and decide. And we've thought about our tooling and what we should consider with tooling. But now we need to talk about the various elements and components that need to be constructed within that. So we need a library, which will be a repository or a collection of all of our Decompose scripts separated into their components. Again, going back to Amazon, so this would be your login script. That could even be subdivided into inputting the email address and password into script A, and in script B, clicking login. It could be a script for performing various different types of searches with different types of parameters. You could have a master script, and within that script, you could supply variables, for example, that will search for different things. And those variables can be interchangeable. You want to have test data. So you want to have databases of your most commonly used and frequently queried data. And you need to have your scripts configured in a way that they can readily call on this data when they need to. To do that, you probably need helper functions. Helper functions can be automated, they can be manual, but essentially what they are is they're just little pieces of code that allow us to perform different checks. So for example, you can attach a helper function to your script to test that the database connection is alive. because if it's not, then we won't be able to get our sample data, and our script will run with nothing and probably produce an error. Going back to your test environments, everything you plan to test from a coverage perspective, that you have it readily available. Your modules. So a combination of, well, really a module is a combination of everything. It can be a single module can be a mix of a test with a few helper functions and a data source. So you could have a module for searching for a pair of shoes. That module will have the piece of code to perform the search function. It will have the helper function to, check the availability of the shoe database or the shoe tables in the database. And then it'll have those tables readily available. And then your hierarchies, which are very important. It's very easy to lose control of your test framework and have test cases and scripts and modules and data scattered sporadically all over the place. And the longer you leave that happen, the more difficult it is to reel everything back in and put it into an organized and efficient fashion. So having a hierarchy or a folder structure of all your modules is very important from day one. Group your modules by what they functionally do or what piece of the application they relate to. Do the same with your data and your helper functions too. So going back to our software development lifecycle, it all comes down to releases. At the end of the day, we're going to release a piece of software, whatever it may be, that is going to go to the users and it's going to be tested. And that is ultimately going, and their feedback is ultimately going to determine the success or failure of that particular release. And what we want to do is we want to leave as little to chance as possible when we go live. We want it to be as smooth as possible, and we want the minimal amount of defects coming back. So when we look at releases, I'm sure many of us on the call today, we're all familiar with the bones of release, the list of all of the changing requirements that have been delivered in a build. And it should equal exactly what the requirements stated. If we produce a list of requirements or feature enhancements to our customers or users, maybe they've supplied it to us, they expect and we want the release to address all of those, or as many as possible of those requirements. When we look at defects again, for example, it's important to